Hey everyone. So today's video we're going to be talking about what is CyFlex. So this is going to be a high-level overview of what this software package is if you're completely unfamiliar with it. If you've already used this software, this video is probably not for you. This is maybe for a new potential customer or for someone interested in using this software who doesn't know what it already does. I've procrastinated making this video for a long time and made a lot of specific videos because I didn't know what level of detail to go into, but I've finally just bit the bullet and decided I'm going to make this presentation for engineers. I am an engineer, and so my target audience is me if I didn't know what this software was. And I jokingly put technical folks who've been told that's very interesting, but I'm not interested at a party. If you're that type of technical person, then this presentation is for you. So, summary, what is CyFlex? So, it is an event-driven software suite with a collection of programs. That's kind of a weird way of describing a software package, but that is what it is. And so, I say it like that because whenever you install CyFlex, you don't double-click an icon and then the software launches. You have to manually decide which programs from our collection of programs you're going to launch. So if you have a laminar flow element in your testing facility and you need to read those values, you're going to make the decision to launch our LFE program so that you can take those raw values and then convert them to mass airflow. So some of these programs are tailored around the engine and automotive testing environment. Things like our engine control task, it's very engine testing specific. And then others are completely generic and configurable for any environment. So we've got generic programs that can handle events and respond, state machines, computation programs, things like that you can control whatever you want. So these programs that you're going to get when you install CyFlex, they can attach to events, whether they're timer events or user created or configurable events to perform various tasks. So at a high level, so if I run send -p, this is how you see what programs are running. This is just a terminal or a shell or the command line interface, depending on who you're talking to. So these are the timers that are running on my system. So these integer values are in units of milliseconds. So I have a slow, medium, fast, and a warp speed timer. And it's 1,000 milliseconds or 1 hertz, 100 milliseconds, 20 milliseconds, and 10 milliseconds or 100 hertz. So in general, we don't recommend running a lot of CyFlex programs faster than 10 milliseconds. You start getting into resource problems on most hardware, but we'll kind of get into that more specifically. In addition to those timer events, which are going to fire at those intervals, so the 1,000 millisecond timer is going to fire every 1 second. And if you have a program that you want to perform calculations or read data or send data every 1 second, then you can have that program attached to the 1 hertz slow timer, and it's going to do what it does at that frequency. In addition to those events, we've got user configurable events, and so you can create an event that's tied to a logical variable so that when it goes true, this event gets triggered, and then you can make any other program do what you want it to do based on that event going off. And so this gives you a large amount of configurability using these event-based functions. So it can communicate and control a wide variety of hardware through protocols such as Modbus, EtherCAT, CAN, and quite a few others. We'll get into all of them later. These three are kind of the common ones that I see on most hardware I'm looking at. And so these programs are primarily configured via text files and command line arguments. So you're going to launch them from a script or manually from the command line if you like. And you're going to give it arguments to say what timers you want it to attach to, arguments to say what priority you want to run at. You can take our general recommendation from our templates as far as the priority, or if you have a program that you think is really important
and you want the Linux kernel to prioritize that over other programs, you can change the priority so that it's more important and it's allocated more of your computer hardware's resources. So you have the ability to launch these programs as well as set and retrieve variable values from the command line. And so this, in combination with creating bash scripts, is going to give you a great deal of customization and automation. The most common example that at least comes to mind for me is creating directories or folders, if you're from a Windows background, based on the unit under test parameters, such as the serial name or the part number. So you could install an engine in your test cell, or install a vehicle on your chassis dyno, or whatever your test setup is. You can create a string variable that's going to contain that part number or a test ID or something like that. And whenever you start the test, you can automatically create a directory structure, as well as automatically launch a data logger, and then automatically run the test. And after it's complete, anyone who wants to see that data, all they need to know is, depending on how you set it up, they may only need to know the part number and the serial number in order to know where that data is. If you're doing multiple tests on the same part number and serial number, then you can have what we generally refer to as a run number. So you can have a directory structure, and then all of your data files might have a .1, .2, .3, .77, whatever the run number is, if you're performing multiple tests. So this tool, the ability to use the command line interface and various bash scripts, it gives you a massive amount of power to automate and control to automate your tests, but you do, of course, need to learn the syntax of bash scripts. There's an abundance of information online for how to do that, but that is, if you're going to take this and reach its full potential for more complex and more automated setups, you're going to end up needing to learn bash scripting. If you just have a fairly simple application where you're going to have an operator or an engineer come in and set up the test, create the directories manually, log the data, and then pull the file off, you don't need to learn the bash scripting. So, it all depends on your use case. We ship our software with this particular Linux distribution. So we run on Linux, and specifically we run on the Oracle Linux Unbreakable Enterprise kernel. It's a specific release of Oracle Linux. It's a Red Hat based distribution. If you're kind of already familiar with Linux, it ships with the GNOME desktop environment and the DNF package manager. So why am I saying this? The main reason I'm saying this is so that you know, in order to use our software, you have to use this operating system. You're not going to run our software in Windows. So if you're new to our software and you're new to Linux, you're going to be learning both at the same time. So it is going to be a steep learning curve. There is not a start menu. There is an applications menu. Even this taskbar doesn't come quote-unquote stock shipped with our distribution. I put it on here by configuring it. You don't have the Windows control panel. You've got a settings menu where you can configure everything. There's a massive amount more control you have as a user over literally everything whenever you're using Linux versus Windows. And as the saying goes, with great power comes great responsibility. So you can break it. And so I think every engineer knows that story. But yeah, this is essentially the operating system, the platform that CyFlex must run on. If you're already a Linux nerd and you prefer Arch or you prefer Ubuntu, as of now, it will not run on those distributions. You need to run on this distribution and a specific kernel. We will provide an ISO for you to install. So we give you everything that you need, but it is locked down at the moment. So next we're going to talk about what protocols does CyFlex support. You'll have to bear with me. Sometimes I'm going to refer to them as programs or protocols or drivers, but it's these things. If you've worked with hardware, yeah, there are these different protocols that you can use. On your system, you'll have drivers that make those protocols work, but yeah, so if you need to talk Modbus or EtherCAT, CAN-FD, BACnet, AK, Skippy, ASAM, or any sort of generic ASCII or serial communication that runs over a serial cable, TCP or UDP, we've got you covered. We have special programs for all of these things that you can configure and run. And so if you have existing I/O or an existing emissions bench or a flow meter that talks one of these protocols, then you can stream that data bidirectional to and from CyFlex and data log and control that device. We also have some custom drivers for some specific hardware. Opto22's Snap series we have a special driver for, but you can also talk to the Snap hardware over Modbus, and then whenever we're talking to their latest series of Groove hardware, we just use Modbus. With Gantner Instruments, we can talk to their EQ and X series modules with a special driver, but again, if you prefer EtherCAT or Modbus, you can configure your system to use those protocols to talk to that hardware. Vaisala humidity sensors, Mettler Toledo scales, ABL Indicom, ABL Inca, ABL MCon. Our customers tend to use a lot of ABL equipment, so if we can't, a lot of it uses AK, and so we'll just use AK to talk to that ABL hardware, but some of them require special programs to be written in order to interface with them, and so we've done that. PAMAS particle counters, RFID and barcode scanners, and Unicode drives. I listed Unicode drives because we do have special programs that can set and get archive parameter values on those drives. But as far as actually streaming data, in general, we're going to use either EtherCAT or Modbus for that. What programs come with a standard CyFlex installation? Great question. All of them. So I kind of mentioned this before, but we don't have some tiered system as far as you getting our programs. We don't have a data logger that supports two variables and another one that supports 10. You just get Flogger. Flogger is our data logging program. You can put as many variables in your Flogger as your system will allow, and you can run as many Flogger instances. So you can run 10 data loggers simultaneously and output to 10 different files if your computer has enough RAM and a hard drive to support that. We have no limit on PID loops as well. This I know is a very common one in the PLC world. There's no special fee for protocols, so if you want to talk EtherCAT, you don't have to pay us extra to get that program. It's just going to be there. And then there's no special hardware required. So we don't have some plug-and-play hardware that we're telling you you have to buy directly from us. You can use whatever hardware your heart desires. And then your primary limitation is going to be your hardware. And in this time, when I say hardware, I'm referring to your computer. So we don't have a software limit that says once you launch 5 data loggers, we're not going to let you launch the 6th. We'll let you launch 100. But it's up to you to actually open up a terminal if you've added a whole lot of things to your system and run TOP, which is a terminal-based system monitor to see how much of your resources you're using. You can see because I'm recording this on here, I've got an 8-core system and I'm using a lot of CPU on every core while I'm recording. And then you're going to see how much RAM you're using down here and then how much of your swap. So if you all of a sudden have some tests coming up where you're going to need to utilize a lot of data loggers or a lot of control loops or something like that, then it's going to be up to you to make sure that you're not overtaxing your system and your hardware. And if you do find out that you don't have enough RAM, you can put more RAM in that system, and then you can run more data loggers. So we're not going to limit you from a software perspective, but of course you are still limited by what your computer is capable of doing. Next, we're going to go through just a list of some of our generic programs and some of our, engine testing specific programs. So we have a program called Event Response, which is a PLC emulator. And so this is a generic tool for configuring what happens when certain events are triggered. In general, because most of our other programs can attach directly to timer events, this isn't the file where you're going to say every 1 hertz do this. You can, and sometimes there's a use case for that in event response, but in general, this is where if you've created your own event that's tied to, say, a digital input that's reading the status of a flame detector, you can configure this program that when that event goes off, you can configure other outputs. So you can, from here, you can set variable values directly, you can launch scripts, you can set other events, you can do conditional checks that says if there's a flame detect and the engine's running, do this, but if the engine's not running, do that. The possibilities are kind of endless. We also have a generic computations program. Gen labels is the file that you're going to edit, and here you can create new variables. You can create real, integer, logical, and string variables, and you can operate on array variables. You'll create the array variables in another program and spec file, but you can do mathematical or any of these operations that we list here on array variables. So mathematical operations, bitwise operations, conditionals, comparison operators, string manipulation, unit conversions, and other special operations. Quick note on units. So CyFlex is going to use standard SI units for all its calculations. So even if you create a variable and you say you want it to be in units of Fahrenheit, we're not going to do those calculations in Fahrenheit. We're going to convert to base SI, do the calculation, and then convert back to Fahrenheit for your display purposes. Let's see, so then we also have a general purpose test manager. Some people would refer to this as a state machine, but if you have some sequential operation that you need to do certain things based on a certain state of the system, then this is a program that we would generally use for that. So a lot of times we're using this for like turning on dyno drives where in one mode we use the term mode to refer to these states. So in one mode you're going to turn on the drive and enable it. In the next mode you're going to check that the bus voltage increased, and then in the next mode you might reset the faults. Mode after that you might check that the faults were reset successfully, and then you can go to this state if they weren't and that state if they were. We've also got switch statements. So another common application for this is you might tell an emissions bench to 0 or span, and it might send an integer value back that could be a few different things. And so you'll have a mode to send the message, a mode to receive it, and then a mode to look at that integer value and then use a switch statement or a case statement is what it's like if you're familiar with case statements, to say if it's equal to 1, then do this. If it's equal to 4, do that. If it's equal to 99, do this other thing. So we've got that capability. This is a very powerful and configurable program. It's kind of crucial to what CyFlex is, this GP test, general purpose test manager. And then we've got a limit monitoring program. So you can monitor variable values. You can also just bake in computed expressions based on the variable values. And if it exceeds an upper or lower limit, you can set certain events and do certain things. We've got data logging. We've got a program called Flogger. I've kind of already touched on that there's no limit. We log in .csv files. In the future, there's a new hyperlogger or Hogger program coming out. It's still in the beta phase, so I won't go into detail on that, but it's got increased speed and it can log to a database and has some cool new features because of that. But we do have data logging, and you can run as many loggers with as many variables as you want. We've got a user control program, so called user control task, so setting up PID control as well as feed forward. And I already mentioned there's no limit on the number of loops. We've got configurable operator displays. This is the one I have running on my system right now. Last week, actually, I converted it to dark mode, just curious if it was able to do it, and it is. And here you can see, I've got some logical variables. This could be tied to a digital output, and you can change the value of it. I've got some programs in the background that are changing it back. We've got buttons. These buttons can be configured to do basically whatever you want. You can launch a script, you can set an event. Yeah, you can do anything from these buttons. This is just a tail. This is showing what's at the bottom of a text file, which is a trace file of what GPTest has done. LED indicator lights for different logical variables. We got a string variable being displayed down here, the variable itself, and then its value over here. But yeah, we've got a configurable operator display. We don't have some standard display that you just get when you purchase our software. You have to open our operator display designer tool and design your own. And designing a simple display is simple. Just designing a complex display is complex. So yeah, know that going into it. We've got some statistics programs. We actually have a few, so just suffice it to say if you need to do statistical analysis, we've probably got you covered. You can create arrays that contain real, integer, logical, or strings. And then we've got a watchdog functionality built in. So we've got this program that monitors whether or not all the other programs are responding and doing what they're supposed to do. And if they stop, then if you've configured that program as safety critical, then we will stop toggling that watchdog. Now the watchdog is just a logical variable, but you can tie that logical variable to a digital output on your system, which could be tied to a safety PLC, and that safety PLC can actually be what says, oh, CyFlex has stopped responding on a critical program, and then the safety PLC can be hardwired to put your automation system, your test cell, your air handler, whatever it is, in a safe state. In addition to those, we've got some niche programs. Most of these are kind of engine testing or automotive testing specific. So we've got a dyno and engine throttle control program. We've got continuous fuel measurement system controllers. So this is kind of tailored to a specific hardware design that you could build yourself, or we've got details on that design on CyFlex.com. But we have a program that's essentially tailor-made to fit that type of system. We've got a bunch of airflow measurement applications. In general, with airflow measurement, you're wanting to know the airflow rate, either in mass or volume, volumetric flow rate or mass flow rate. But devices such as an LFE, some of these don't output what you want, so directly. So if you've instrumented your own laminar flow element with a differential pressure sensor, gauge pressure sensor, and an RTD, then you've got those values coming in. Well, we've wrote a program where you can just feed our program those values as well as the calibration coefficients, and it's just going to do all of the calculations for you to output mass airflow, so you don't have to deal with doing those calculations yourself. And so we've also got similar programs for ultrasonic meters, subsonic, Venturis, Coriolis meters, etc. We've got some emissions analysis programs specific for 1065 certification, load bank control programs if you're doing genset testing, internodal data transfer. So if you've got multiple CyFlex systems at your site, we can send those variable values back and forth between systems quite easily, and we can also send events back and forth between those systems quite easily. Volumetric efficiency calculator, drive cycle simulation tools based on MATLAB simulations, and then we've got an entire kind of suite that just comes with our software for particulate filter weigh room control. So we can, I mentioned earlier, I think we've got a custom program to talk to those Mettler-Toledo scales, and you can also use our generic serial protocol to talk to others if you've got one that's not a Mettler-Toledo. And then we've got barcode scanners and a special program for handling the environmental control requirements of those weigh rooms.
So in the next segment, we're going to talk about what can CyFlex control, and a better way is discussing what has it controlled. To some extent, CyFlex is like a PLC, and so asking what can a PLC control, well, the possibilities are kind of endless. It's a generic enough tool that it can control whatever you're capable of configuring it to control. But
What has it controlled? This isn't a comprehensive list. This is stuff that I've seen in my career here. But CyFlex has controlled water brake, eddy current, motoring dynos. It's controlled fuel measurement systems, not either as the main data acquisition system controlling a fuel measurement system. We've also installed dedicated UNO CyFlex PCs on fuel measurement systems that roll around on carts that can be integrated with CyFlex or non-CyFlex test cells. It's controlled air handlers, both for combustion air and test cell ventilation. It's controlled airflow calibration rigs, automated dust metering systems for intentionally contaminating fuel to see when injectors fail, automated liquid fuel blending systems where we cooked up a brine solution and then metered that in by mass so that we knew how much of that type of contaminant was going in. Gaseous fuel blending systems, so if you've got a system where you're trying to deliver certain percentages of natural gas or propane or CO2 or any other gaseous fuel or gaseous combination, we've set it up to control systems like that. Emissions benches, we've done this both where CyFlex is controlling the hardware directly, the solenoid valves for the gas train, and we've also done it where CyFlex is simply sending commands to a standalone AVL or Hariba or other emissions bench saying, 0 span, and then we wait and listen for its response. So we're just the master controller telling it what to do, but it has its own standalone Windows computer from the manufacturer. We've controlled CDS tunnels, smoke meters, Celesco meters, particulate filter measurement devices from a variety of manufacturers, opacimeters, set sensors, PM measurement. I guess that's a little redundant. Rear-wheel drive, all-wheel drive chassis dynamometers. I've personally seen one setup where CyFlex was controlling 4 dynos simultaneously for doing an all-wheel drive transmission test, and it was also indirectly controlling shifting as well. Battery cycling controllers for automotive battery testing. Motoring dynos that were coupled to electric motors that were vehicle electric motors for electric vehicle motor testing. Abatement systems for facility-wide exhaust after treatment. Thermal chambers, oil degradation rigs, natural gas burners for accelerated catalyst aging, and a lot more. I mean, that's kind of a high-level list that I threw together of things that I've seen, but the idea is it's generic enough that you can set it up to control all kinds of things, whatever your heart desires. So what type of user is CyFlex ideal for? CyFlex is not perfect for everyone, and so I kind of tried to make a couple slides here to detail who our target audience is. So the ideal CyFlex user, this one bullet point is really the meat and potatoes of who our ideal CyFlex user is. You need to have a team of support personnel who are already comfortable or willing to become comfortable configuring the software through text files, working from the command line interface. So if you find this intimidating, and you're not willing to conquer that intimidation, then this might not be for you. And then configuring and customizing the Linux environment to suit your needs. What am I talking about here? I touched on it earlier, but a lot of the things that we're going to do are going to be handled through bash scripts. There's an infinite amount of knowledge on the internet that can teach you how to do these things, but setting up automated file transfers from your test cell to maybe your central node so that you can back things up, and then just even down to like this taskbar. Like if the taskbar is something that is configured on this system, it doesn't come by default. The GNOME desktop environment doesn't come default with the taskbar. I personally like the taskbar, so I use it. I came from both Windows and KDE, and so I'm used to a taskbar. So, yeah, at a high level, I mean, if you hate Linux and you hate text files and you want a GUI-based software package where you pop up a graphical user interface and you configure your software through there, you shouldn't use CyFlex, because we don't have that, just plain and simple. And then installing packages using the command line interface in Linux package managers. I kind of touched on that earlier, but you're going to have to install things from this interface. You're going to have to type sudo dnf install and then your package name. It's not hard to learn, at least not in my opinion, but yeah, it's another tool where there's not a functional graphical user interface. Who should turn to our competitors? A team, I had said this already, but a team who requires graphical-based software configuration. We don't have that, and it's not coming in the near future. So if that's a hard requirement for your team, then this software package is not going to be for you. A team with an immediate need to run large numbers of programs faster than 100 hertz. We generally don't recommend in a testing environment to run our timers that I was referring to earlier faster than 100 hertz. Can it be done? Absolutely. Have I run CyFlex and streamed data over EtherCAT and logged it at 1,000 hertz successfully? Absolutely, I have. But when you start getting into these higher data rates, you are going to start wanting to have dedicated systems that are just handling those higher data rates. So the main data acquisition and control system that you have controlling your test cell or your test environment, you probably definitely don't want to also throw 1,000 hertz timers at it and then start streaming large amounts of data at those data rates. And then this last one, again, I touched on this, but a team who wants to pay extra for plug-and-play hardware. So you do have to manually configure our hardware. With that versatility of us having a bunch of generic drivers or supporting generic protocols, you're going to have to manually open a text file and configure the particular piece of hardware that you're wanting to talk to through that text file and troubleshoot it and get it going. You're going to have to learn about EtherCAT slave addresses and master addresses and Modbus registers and variable types and things like that in order to set it up. Some of our competitors, Duosoft comes to mind. I think ABL is similar. You can buy their software from that company and you can buy hardware from that company, and when you just plug it in on the rack, it automatically discovers and creates some generic variables for you to work with. We don't have that. And so if it's a hard requirement for your team that you don't want to learn those, you don't have anyone interested and or capable of learning how to configure this type of thing, then you should definitely check out some of our competitors, Duosoft, ABM. This is just reference material in case this PowerPoint slide ends up on our website. We've got a YouTube channel with videos showing how some of our programs work. This is our company's website, and then this is a link specifically to the manuals of CyFlex. I said that the target audience here is engineers, and the manuals are, this link is where the engineers are going to spend their time on our website. We also have a bunch of usage pages on the website for how to use our programs and launch them, but you can also, once you have the software, just type use and then the name of the program, and it's going to tell you how to use that program. If you're familiar with Linux already, it's the equivalent of typing man to see the man page or the manual. And then one last thing, if you have questions or you're interested in our software, then you can email us here, or you could potentially comment on this video, and we might periodically check and see it. So I would recommend sending an email here if you'd like to learn more about the software or have a discussion. So thank you for your time.